Hi, this is Mike Cobbett, and I'm going to introduce the topic of Galasa Configuration Property Stores, followed by a demo from Savas. I'm going to talk about what a CPS is, some conventions we use for naming properties within the CPS, how managers and test cases can each use properties within the CPS, some other features, and we'll finish up with a demo of interacting with the CPS directly. So what is the Configuration Property Store? Well, it's a collection of properties. So a property is a name-value pair with the segments of a property separated by a dot. So this is my property name has three segments: a prefix, a suffix, and an infix. And you can set them to be whatever you want. Whatever your test case or manager needs to have, you can supply a value. So we have multiple properties within a namespace. So a namespace helps to group the properties together so that it restricts what you can draw values from. For example, test cases can only draw from the test namespace, and managers draw from a namespace the same as their manager name. So we can have multiple namespaces in a configuration property store. Properties are set up and then they're used by the framework itself to control some behavior of the framework and the Galasa Ecosystem. But mostly it's managers getting configuration about the manager or test cases getting values to control the test behavior. CPS properties have naming conventions that we like to stick to. In general, each segment of the name is lowercase, apart from pieces of the property which are variables that describe a specific instance of that property. But in general, if I wanted to identify this property at the top here, I would say prefix of zos.image, an infix of my ZOS host 1, and a suffix of telnet.port. And that would get me the value of 86 out, which I could then use to control which port I connected to. In your test code, you can do things like this. There's an annotation called test property, which comes from the core manager, and you could specify the prefix, suffix, and a list of infixes. The prefix must always match, the suffix must always match, but the infixes are a list of possibles that could match in the middle of your property. And there's an implicit empty infix involved in the matching. Anyway, so you put this in your test case, run your test, and Galasa will inject the value into your variable, my property in this case. It's supplied by the core manager. You can go and look up to see more about the annotation. But another important thing to remember is that all the test properties are in the test namespace. So if you're setting up a property, make sure it's in the test namespace if the test is going to draw on it. Managers also use CPS properties a lot. We could have a look at any of the managers in the documentation and we'd see a configuration part, and this goes through each of the properties that it wants set. In here you'll notice the KixTS is the name of the manager, that's essentially the namespace, and extra bundles is the property really. So lots of managers have need for configuration, and they're all documented on the website in Galasa Dev. The CPS can also provide this fallback mechanism where if you specify an infix of my ZOS host 1, you'll get the top one if these are the available properties in the CPS. But if you specify my ZOS host 1 and it's not found because the property isn't in the CPS, then there's like an implicit match on things that don't have an infix. So we can essentially describe this as a fallback mechanism. So if the configuration is missing, it'll fall back to this. And this is very useful if you've got specific port for a particular host, say in this case, but you've got a general port that is different that you want all the other hosts to use. In this case, they're both set the same, so it wouldn't have any effect falling back. But if you wanted to set this one to be something odd for this host, then you could. There is a way of overriding any of these properties for each test. So when you launch a test, you can specify overrides, and that will override what's in the CPS. And the overrides will be looked for in preference to the contents of the CPS. We can use the command line CLI tool or Eclipse to run tests locally. And when they do, the CPS properties are drawn from a file. It's called cps.properties, and it's available in the Galasa home, which will usually be in your home folder in a folder called .galasa, unless you've set the Galasa home environment variable. If you're putting a property into that file, you put it in with the namespace and then the rest of the property name. So this would set something to control the framework. When you're using an ecosystem to run your tests in, so not running the test locally, there's a REST interface you can use in order to retrieve and manipulate the properties, or you can use the Galasa control command. It's a command line tool, and I'd like to show you the demonstration that Savas is going to provide.
We have created some CPS endpoints that can be used to look up properties based on namespace, prefix, suffix, and infixes. First of all, I'm going to show an example of what it looks like in the API endpoint in and of itself, just so that we're a bit more clear. So this is essentially what I have been playing around with on my local system, and these are the properties that are currently sitting on my local etcd instance. In order, obviously, to actually get those properties rather than going to that API endpoint, we can use the properties get command, as I've already pre-filled it here. So you can do Galasa control properties get, and obviously you have to provide the namespace for it that you're going to be querying, because that is part of the URL structure, so it is a mandatory field. Once you do, but you can see all your properties as they have been set within Galasa for that given namespace. We can also further enhance that query by using the prefix, suffix, and infix flags. So, for example, if I just do a prefix test, in this instance, we can see that the number of results has decreased to those that start with test. Once again, the same applies to suffix, where I don't have many options on here because I've just reused everything. So we're going to get the same test results in there, but we can also use, trying to remember back if this is infix or infixes.
Sorry, Sabas, before you do the infix example, with that suffix, could you provide a suffix of, for example, river.stream?
Yep.
Cool.
So if I run this one essentially with the river.stream, you can actually see that it gives us back the two results that match.
Grand.
Prefix of test and a suffix of river.stream. So yeah, so you can actually combine those in all the fields as well. So if I just further narrow that example, so if we know that the prefix is test.flows, in this instance, we'll only get that one result that matches that property. So these prefixes and suffixes, as well as the infixes, can take essentially a combination of parts that we already know. So if I put infix in here, we can put the word like in there, and you can see that once again we get that exact same result. We can also search for multiple infixes. So if we comma separate them, we can actually use two different infixes, and it will actually look for results that contain either or both. So it effectively acts like an or statement. The other thing to probably add here is that obviously if you do know the name, rather than having to break it up into all the different parts, you can use the -- name for that specific property. So s.water.stream, for example, and you can get that single property there. That's all about the querying, but obviously there's more to the magic, which I suspect everyone will be interested in. So let's first of all talk about updating a property. So updating and creating both use the property set command. And again, we have to provide the namespace, but in this instance, we can't do it based on a query. We have to provide the full property name that we want to create in here or update, as well as a value. So if I were to, for example, change this property to be a hello world, at this new value, we can see that we get a message back to say that that property has been updated within the namespace of framework. So if I go back to the query then and search for that, we can see that it's now been updated to a new value. Equally as much as mentioned, you can use that to create a new property, and this is where you might get into a bit of a dangerous territory, because if you make a typo, for example, if you miss out a dot in that name set, yes, thank you, sorry. There we are. That's the same. So, like I said, if you miss a dot, for example, where you're trying to split the different sections, the endpoint is going to see that as a new property. So it is going to create that property essentially. So if I just do a full query with no parameters on here, we will see that this new property is going to show up right at the bottom there. And obviously, to finish off, especially considering that we've just made a typo, if we want to fix that, we can use the properties delete to remove a property. Delete. And once again, this just takes the namespace and name. So the namespace in which we'll find the property and the name of that property. So once I fire that off, we once again get a message to tell us that it's been successfully deleted. And if we go back and do a query, we can see that that property has gone as well.